In simple terms, a microservice is an architectural style where an application is divided into small independent services that can communicate with each other with well-defined APIs. Each service is self-contained and focuses on one business capability. And this approach contrasts sharply with the traditional monolithic style where all the services are coupled together into one code and run as a single service. But in my opinion, why these became very popular in the last few years has something to do with the rise of the internet. Let me explain. If you imagine the start of commercial internet back in the 90s, where a couple of guys realized that there's all of these websites but they're not searchable, so they invented Google. And at the time there were not a lot of people actually using the internet. It was not as widely available as it is today. So traditionally all of these websites were just one service, one server serving all the users. But as the number of websites grew and the popularity of these websites grew, so did the availability of the internet, so a lot of more people were actually visiting these websites. So traditionally all of the websites were using the monolithic architecture, which means everything will be in one place, one repo, one server, all of the services that the website offers all in one place. And as demand grows, we can scale that horizontally, especially with the start of the cloud. We can scale horizontally and vertically and basically serve all of our users. But what if only one part of the website has all of the users? With monolithic architecture, we couldn't really scale only one part of the application because everything is coupled together, so we would need to scale the whole server. And I think the big break point was when social media websites became very popular. Imagine serving 1 billion users, and that's all the active users that Facebook had very shortly after they became popular. And having one server serving 1 billion users, that's a big number. I mean, could you imagine the amount of data they would have with all the pictures, all the posts that everyone was posting on Facebook or maybe YouTube where all the videos is just insane. And when you have an application like that, we need to get more creative in how we can serve all of our users whilst also providing a good service. And we could do a lot of stuff like caching, vertical and horizontal scaling, compression of the data, of the images and the videos, for example. But we could also divide the application into multiple microservices. With microservices architecture, each microservice can be developed, deployed, operated individually and independently of the other services. Now, this modular approach means that if one server requires additional resources, we can easily scale that one microservice. And because now these are all separated, we can use different technologies like different languages depending on the microservices function, which allows for a mix of technologies for the best of the product and provide a better experience. This flexibility enhances the efficiency and effectiveness of the development process, and each team can utilize the best tools and practices for each service individually, tailored to that unique service. Now let's talk about some of the key benefits of microservices architecture, which is becoming more popular because of all the advantages they have. The first one, I think, is agility. Because these are now independent individual microservices, the teams can work on them individually. They can be tested and developed and deployed all on their own, and reduces the chance of different services clashing into each other. And it's also much easier to manage bug fixes and releases. Additionally, if something goes wrong, we can quickly roll back to the previous version without affecting the rest of the system, ensuring that the application remains stable and functional. Now, the next one is connected to the first one very well, but it's the fault isolation. If one of the microservices goes down, something goes wrong, it's not going to affect the whole application. It's just going to affect that microservice. And because these microservices are all individual, a failure in one microservice can be managed separately and not affect the whole application. This is crucial for maintaining high availability and reliability in our apps, and it ensures that our application can run even when failures occur in certain services. And I think with isolating the microservices, we can also improve the troubleshooting of any issues that occur. And as I already mentioned, scalability is a big advantage of microservices. This means that if we have a load only to one microservice, we can scale it up efficiently and we can allocate resources more effectively and more efficiently. But this really enables us to handle peak times smoothly without overburdening the whole system, and thereby optimizing the performance and maintaining stability across the application. While there's a lot of benefits for microservices architecture, there's also a set of challenges that comes with it. For instance, the more microservices we have, the more complex our monitoring system becomes. Because now we have multiple systems we need to monitor and keep alive, and it's just more moving parts. To navigate this complexity, we'll need good dev operations culture and sophisticated login tools to help us monitor and keep track of all these microservices to ensure that each of them are running smoothly without any issues. And the other big one is data consistencies. Because each of the microservices will keep their own data, it can be very difficult to keep all of this data consistent across each of the servers. And it usually means that we need to embrace eventual consistency in our application. What this means is that the data will not be consistent immediately, but eventually it will be consistent. And this really requires a lot of planning beforehand to make sure that our systems are designed in a way that this can actually work and not cause any issues in our application. And there's also other strategies that can be implemented when it comes to data consistency, but essentially this will really require for a lot of pre-planning and designing the system in a good way and understanding the business requirement as well, so we can design the system that work well for those requirements. Overall, one of the biggest problems I see in the tech community is that people just blindly follow whatever's popular at the time. And I think microservices is one of those things. I mean, everybody, even indie hackers or solopreneurs, whatever they call themselves on Twitter, people will just go with microservices because this is now the buzzword, and everyone just implements it, make the applications too complex without the need for it. And before anything, we need to understand the requirements and make sure that whatever solution we have is the easiest solution we can implement to meet those requirements. Now, obviously, this doesn't mean cutting corners. It just means that if you don't actually need microservices, there's no need to implement microservices. You can still implement one monolithic type of architecture with the forethought of you may need to move this into microservice in the future and make it easy and build in a way that can be easily done. But yeah, microservices still are great to use, especially in a big system that needs to scale very fast and scale a lot. But hopefully now you understand why they're useful, what are some of the benefits. But yeah, that's been pretty much it for this video. Hope you enjoyed it. If you have any feedback, put down in the comments below. Thank you very much for watching. Enjoy the rest of your day. Happy coding. Bye.